All right, so the next thing that we're going to be learning about is characteristics of polynomial functions. So, throughout this unit, like I've showed you guys a lot on graphing calculators, but for this unit, we're going to take a little break from the graphing calculators and we're going to use Desmos just to make our lives a little bit easier. So that's why this video looks a little bit different than normal because this is the easiest way for me to give you guys a video where I use Desmos to show you guys some things. So for the first problem, we are reviewing domain and range. And so just a reminder, domain is all the x values, all the inputs that are defined in the function. And I know it says it in the definition, but I'm going to go ahead and write x next to domain, kind of big, so that I don't forget if I ever glance down at my notes when I'm using them in class. So for this particular problem, we don't need to graph it in Desmos to see it because we can get whatever we need from the picture to start with for the domain. So for the domain, we're thinking x values, so we're thinking left to right. So if I look at this picture, the left side of the picture is an arrow, the right side of the picture is an arrow. So an arrow on the left and an arrow on the right. Left arrows and right arrows are always just infinities, and a left arrow is a negative infinity. A right arrow would be a positive infinity. And so if we write the domain, we're always going to write our answers from left to right. And so I can write negative infinity first and positive infinity second. And then infinities always get parentheses. All right, so that's the domain. Next, we're going to do the range, which uses the y values. So I'm going to write y next to this so that I don't forget. And for range, we go from the bottom of the graph to the top of the graph. Now, if this was one of the graphs that we've studied so far, a quadratic or an absolute value or something like that, then we could figure out what the top of the graph was because we'd be able to look at the vertex. But polynomials don't have a vertex. So for this, we're going to have to take the equation and we're going to have to type it into Desmos so that we can graph it and figure out what that point is right there. So I'm going to go ahead and switch my screen over to the internet, and we're going to open a new window and go to desmos.com. Go to the graphing calculator. And everybody should be doing this following along with the video. You can type y equals or not type y equals. Desmos doesn't really mind if you use it or not. And then here we've got negative x to the fourth. And for us to do an exponent, you have to do shift and then press the 6 key, shift 6. And then you can type the fourth, right? Shift 6. Now, if you're using your cell phone, then you would have this keypad down here. In the bottom left screen, you can see the keypad that I just opened up. And you would be using the A to the B button right here, and that would allow you to put an exponent in. Okay, so negative x to the fourth. Oh, let me delete that. Now to get out of that exponent position, I'm going to hit my right arrow to get out of that, and then I can start typing the rest. Plus 2x, again, shift the 6 key, x to the second, over plus 2x minus 2. Okay, and I just want to know what this point is right here. So all I have to do with Desmos is click on it. And since I'm looking for the range, all I want is the y value. All right, so the bottom of the graph is arrows pointing down. These arrows pointing down would be negative infinity. And then the top of the graph was that point. Let me switch screen. Sorry, I was writing. You couldn't even see what I was writing. So let me go back. Okay, so the bottom of the graph is arrows going down, so that's negative infinity. The top of the graph is that point, and if we look back at that point, since we're thinking about up and down, then we want to make sure that we use the y coordinate. So I'm going to label the graph with that y coordinate, which was 1.207. So I went ahead and labeled that in my picture. And so now the range is from bottom to top. So negative infinity, 1.207. Now, infinity always gets a parenthesis, and then the number gets a bracket if you can touch it with your finger. So if I can see, like, where's the 1.207? Oh, it's right there. Then I should put a bracket. All right. The next set of problems are for increasing and decreasing intervals. So here is where I always put a stick figure, and I have my stick figure walking uphill and walking downhill. So just a reminder, whenever we do the increasing and decreasing intervals, both of these are x values. So I'm going to write x really big just so when I glance at my notes, I won't forget that. And so I'm going to put my stick figure on the left side of the picture. And when I start, my stick figure is, if he starts walking, he's going to be walking uphill and it's going to be very steep uphill. So my stick figure is going uphill up until he reaches this point right here. And then once he reaches that point, then he's going to start going downhill. Then he's decreasing. And he's decreasing until he hits this point right here. And then he is increasing again. And he's increasing all the way to the arrow. So what I need to do is I need to find the x value right here because this is where he starts, the x value right here, the x value right here, and the x value right here. So since they are x values, I'm thinking in terms of left and right. So a left arrow is a negative infinity. A right arrow is a positive infinity. And then to find these other x values, I'm going to go ahead and graph this equation. So I'm going to go back to Desmos and I'm going to type in the new equation. So y equals x to the third plus 8x to the second plus 16x plus 7, right? And I might need to zoom out a bit. Okay, and if you click on the points, they will show you. Okay, so the x value at the very top is -4. The x value at the very bottom is -1.333. And so I went ahead and I took those values and I labeled just the x value in my picture. So I have -4 right here and -1.333 right here. So for the increasing interval, I have two answers, increasing, increasing. So my first increasing interval answer is from -infinity to -4. So I'll write -infinity to -4. And when I do increasing intervals, there are parentheses around both sides. And that's because when the stick figure is standing here at this moment exactly, he is not still walking uphill. He's at the very top. He's in between uphill and downhill. So over here, we put a bracket because we could include the number. We could say the possible y values. Yeah, that's a possible y value that's included. And here, if we're talking about where the stick figure is walking uphill, this value is not included in that. The other increasing answer is right here. It's in between these two numbers. So the other answer is -1.333, comma, infinity. Again, two parentheses. And now, since we have two answers, I'm going to show you something you've never seen before. And that's that we put a U anytime we have two answers. It means union. It means that those two answers have to go together. It's not one answer or the other. It has to be both at the same time. If you don't put the U, that doesn't bother me, but you'll always see the U on my answers. And I just don't want you guys to be confused about it. All right. The decreasing interval is, so here's the word decreasing. So the decreasing interval is in between these two numbers. So the decreasing interval is between -4 and -1.333. Okay. All right, next we have a max and a min. The maximum is the location of the highest value of the function written as a point. So for us, we're going to think of this as a mountaintop. So in the previous problem, we had a maximum right here. A minimum is the location of the lowest value of the function written as a point, and we think of this as a valley. Right down here, this is a valley. There can be more than one. So we could have two maximums, two minimums. We could have one maximum and no minimums. You have lots of different options, especially in polynomial functions. So let's go ahead and flip the page over, and we're going to look at just this last problem and write down the maximums and minimums, and then we will be done with the video for today. So I'm going to go ahead and go back to Desmos, and I'm going to plug this function in. So I've got y equals x to the fourth minus x to the third minus 4x squared plus 5. Okay. And I can see a minimum right here and a minimum down here. So I'm going to go ahead and write both of those points down. And the nice thing about Desmos is that they round for you. So I already have my answer written to 3 decimal places. So I'm just writing this. You should be writing it right now too. Hopefully you're taking just as long as I am to write it down. Negative 3.31. The second answer probably only has 2 decimal places because my guess is it's negative 3.310, and that's why they didn't write the other one. So I'll go ahead and show you guys what I have written on my paper so far. I just wrote down those 2 points. I did not put a U in between because our answer was a point, an X and a Y coordinate. And when you write X and Y coordinates, you don't have to put the U, which is why you guys have never seen that before, because you guys have done problems where you wrote multiple points and never had to write a U. All right, now let's go ahead and find the maximum. So go back to Desmos. I will just click on it. It is the 0.05. So let me go ahead and write the 0.05. There's our maximum. And so we are done. We will finish the rest of the notes when I see you guys in class.